What up? What up? I'm just getting set up here a little bit. Um, I want to go over some of the problems on a book I wrote about, actually, it hasn't even been a full year. But this is Math a Day, which is a collection of 365 problems that you can complete once per day, which is actually really fun. I found it to be a little challenging for myself and for some students. And I just think it's overall a great way to increase your math skills and just continue to get better at it. Um, I'm currently trying to log on to my other account so that I can be a co-host on here. Give me 1 second. I'm only going to be on for maybe like half an hour. I just want to go over a few problems. I just think it'll be kind of fun. Um, okay. I actually don't even know what my actual password is, so I'm probably going to be screwed. Just so you know, I can't see who's on the chat, but if anyone's on here, hope you're doing well. Hmm. Uh, Maybe that's my username. There it is. I think I found it. Wrong one. I don't know my password. Jeez, isn't that crazy? That's my username. Let's see. Let's try one more time. Log in. I don't think it knows my password. Okay, I guess I don't know it. Let's log in. Let's try to log in one more time. Let's try to use email. Maybe Facebook will work. I hope everyone's having a great day. It is Tuesday. I'm actually off work kind of early today, which is kind of nice. Can't see who's on. Anyway, just wait till I log on here. I just want to be able to see the chat as I'm talking. Oh, I found myself. Yo, buddy. Okay. I see myself. Let's go. All right. Anyway, so this is the book I wrote, and I just saw that it was less than a month ago, less than half a year ago, or 6 months ago, which is kind of nice. Collection of 365 problems for you to review. It is available on Amazon, on my website. But again, one problem a day, whether it's challenging to you or not, that's totally up to you. So I'm going to go over problem one real quick. I'll probably do like maybe, 2 or 3 problems and then just call it a day. But anyway, yeah, so this first problem, they're asking to find the point of intersection. Quite simple. You just have to go ahead and set the equations equal to each other. There's like a little click over here. Okay, I'm going to move that just a tiny bit. Anyway, if we're just trying to find when these two things are equal to each other, I'm just going to go ahead and just kind of distribute this, expand it, and I get negative. This is x squared minus 6x plus 9 plus 5 is equal to 2x minus 4. All right. Be very careful with this negative sign that's outside the parentheses. I'm going to have to distribute that to every single term in that parentheses so that this becomes negative x squared plus 6x minus 9 plus 5 is equal to 2x minus 4. And now I can go ahead and combine the like terms. It looks like I have the negative 9 and the positive 5 that I can combine. And this becomes negative x squared plus 6x minus 4 is equal to 2x minus 4. Okay. And because this is a quadratic, I want to move everything to one side because whenever you have quadratic functions, you want to have them set equal to 0. So I'm going to subtract the 2x to the other side and add the 4 to the other side. And what do you get? You get negative x squared plus 4x is equal to 0 because that negative 4 and the positive 4 cancels out. All right, so in this case, I'm trying to solve for x. I can go ahead and factor out an x, and I get negative x plus 4 is equal to 0, and I get two values. X is equal to 0, and x is equal to 4. Now, those are the x values. I want to find the y values because they're asking for the point of intersection. So I can plug in the 0 and the positive 4 to any of the functions that I have on top. And I'm just going to plug it into my g of x just because it's a little easier. So on the bottom, I have g of 0 is equal to -4, and then g of 4 is equal to, looks like 8 minus 4, which is 4. So then our 2 points of intersection are 0, -4, and 4, 4. That's problem 1. And again, if you're using this book, you're done basically. You close it, go on to the next problem the next day, but you do this for a full year. 365 problems, 1 day a year. And that is, again, kind of fun. You get to improve your math skills. And at the end, you'll be very surprised how confident and how much better you got in these math concepts. Okay, let's go to the second one. Let me go ahead and scroll down. And it has like a plethora and a bunch of other topics that you can do. Luisa, you're the best. If you guys don't know Luisa, go follow Lulu. Luisa, Miss Escobar, teacher of the year, the boss. All right, problem number 2. I have these parallel lines M and N crossed by a transversal line L, and I have to solve for X and for Y. Again, you can solve this in many different ways. What I'm seeing so far is that these angles right here, 2x plus 5, the 75, and the 1/2 x plus 50 are supplementary. So they're going to add up to 180 degrees. So I'm going to go ahead and create my algebraic equation that helps me solve for that. And I get 180 there. All right. Now I'm going to go ahead and there's nothing really to simplify with these parentheses, so I'm going to get rid of them just so I can visualize this better. And I'm going to go ahead and combine the like terms. I see a 2x and I see a 1/2 x. If you know your fractions, you'll know that this is 5/2 x. And then what I can go ahead and do, I have the 7, the 75, and the 50. By the way, some teachers, when they are talking about combining like terms, they really like to talk about this, creating some shapes. And what I mean by that is look at the 2x and look at the 1/2 x. These are both like terms, so I draw like little squares around it. Right now I'm color coding it, so it's pretty obvious what I'm trying to combine. And then for the constants, because those are not like terms to the x's, but they're like terms to each constant, I'm going to go ahead and put little circles on it so that I can easily keep track of what I'm adding together. Okay, so I have 75 plus 50 plus 7, and that's going to be 132 is equal to 180. All right, now to solve for x, I'm going to go ahead and subtract the 132 to the other side. Let me just go ahead and show my work there. And I get that 5/2 x is equal to 48. And then in order to isolate the x variable, I'm going to go ahead and multiply everything by 2/5. And I get this weird number of 96 over 5. That's okay. A lot of the times, and the solutions here have weird values, and I think that's the whole point. I don't care if you get the wrong answer. It's about just attempting these things. I don't know how many times I've seen math problems online, whether it's Instagram or TikTok, and honestly, I think it's just really, really, really fun just to work on these problems on your own. Okay, so now I've found that x is equal to 96 over 5. Whoops, I put 95 over 6. 96 over 5, there we go. And I'm going to have to erase my work, unfortunately, so I can keep track of things. All right, I need to solve for y. How do I do that? If you see these, then 3y plus 6, the fact that I have parallel lines, I think that's going to be really useful. So I know that the 3y plus 6 and the number up here, the 2x plus 5, those are alternate exterior angles. And alternate exterior angles are known to be congruent. So I know that 2x plus 5 is equal to 3y plus 6. We already know what x is, so I'm going to go ahead and plug that in for the x and get 2 times 96 over 5 plus 5 is equal to 3y plus 6. All right. Now let's go ahead and simplify this. Weird value. You know, when I created these, I thought it was going to be really cool to have like all these weird fractions, but sometimes it's kind of annoying to work with. But they're fractions. I mean, it's life. You're going to be dealing with fractions a lot, especially if you're in STEM or if you're, you know, just trying to take calculus. We just got to deal with it. All right. I'm going to get 192 over 5 plus 5 is equal to 3y plus 6. I mean, there's so many ways that I can combine this, or I can simplify for y. I'm just going to combine those fractions on, or the 192 over 5 plus the 5. That's going to become 217 over 5 is equal to 3y plus 6. And I'm going to go ahead and subtract the 6 to the other side. Okay, so when I subtract this, I get 187 over 5 is equal to 3y. My final step is to divide everything by y, or divide everything by 3, and I get that y is equal to 187 over 15. Booyah. Look at that. This is supposed to be one problem a day for a full year, but if you want to get crazy, do 2 problems a day, do 3 problems a day, doesn't matter. You can complete probably the entire book within, I don't know, a month, 2 months. But again, if you do 1 problem a day, you finish it, you close it, go on, go about your day and come back the next day. It's just going to be so helpful for you. So again, highly recommend Math a Day. Buy it on Amazon. You can buy it on my website. Or you can just follow along with me and just try to solve, each problem that I show up, or whenever I show up on TikTok Live. And I don't know how often that's going to be, but sometimes it's often, hopefully. Okay, for some reason, my screen won't let me erase things, so let me go back. I am going to reshare my screen there. All right, let's go to the next problem. This might be the last one. And then maybe we'll call it a day. Maybe 2 more. Why not? I mean, if more people join, I think that'd be great. Anyway, all right. Let's go to problem number 3. We have these 2 triangles. Hopefully, you can recognize them as a 40, 45, 90, and then we have a 30, 60, 90 up on top. So, if I focus on just let's do the triangle on the bottom. Okay, that's a 45, 45, 90. Now, one of the rules of the 40, 45, 90 triangles is that the 2 sides are the same. So I'm going to give that an x, and then the hypotenuse is always x root 2. So if I do some work on the side, I have x root 2 is equal to 8. I want to solve for x, so I'm going to have to divide root 2 to both sides. And so x is equal to 8 over root 2. I hope that you like radicals on the bottom. If you don't, some teachers say they're not allowed. Once you get to calculus, they give you this bullshit story that like, oh, now we don't care about radicals. They can be on the bottom. Honestly, I don't care. I don't care if they're on the bottom or if they're on top. Do what you want. But I know just a lot of people will be very pleased if I rationalize the denominator. And so this is going to be 8 root 2 over 2 or 4 root 2. Okay, so now I know that my sides are 4 root 2. So I'm just going to go ahead and erase these values. This is 4 root 2, and this is 4 root 2. And they want us to find, well, the perimeter of both shapes. So I got to go ahead and find the other side lengths as well. Well, if you recall, this is a 30, 60, 90 for the triangle on top. The 8 is the small side, and then BC up here is the longer side. So right away, this is going to be 8 root 3. And if you remember your special right triangles, the hypotenuse, which is CD, is going to be 16. All right. Now that I have every single side, I can go ahead and find the area. Now remember, the area is going to be the area of the bottom triangle, and that's going to be 1/2 times 4 root 2 times 4 root 2 plus the area of the triangle that's on top, and that's going to be 1/2 8 times 8 root 3. When I create these problems, it's almost like there's a lot of things that you have to know, but these are all math survival skills that are really going to help you along the way. The 45, 45, 90, a lot of people might have not remembered that, and they would have used SOHCAHTOA. But when it comes to finding area, you might not have You might not have remembered the area of a triangle, so that's something that you should definitely look up if you don't remember it. But again, that's okay. That's the whole point. You want to, just explore these things. Get the wrong answer. It doesn't matter. It's all about practice. Okay. So for the first area, this is 16. This is 32 over 2 plus, and this is going to be 32 root 3. So if I simplify this, this is 16 plus 32 root 3. You can write it as a decimal if you like. You can use a calculator. Totally up to you. All right. Found the area of the bottom triangle. Now I'm going to go ahead and find the perimeter of both. How do you find perimeter? Keep in mind, it's just the length of all the sides. Here's the thing. A lot of people get so confused with that 8, and some people start adding that. Don't fall for that trick. Don't fall for it. Could be fucking annoying, but you just have to make sure that you just add up all the sides, because that will be the perimeter. The 8, no, not part of it. Okay, so my perimeter is just going to be 4 root 2 plus 4 root 2 plus 16 plus 8 root 3. And look at this. Beautiful, beautiful 8 root 2 plus 16 plus 8 root 3. You can leave your answer like this, or if you really wanted to, you can go ahead and do 16. Oh, I can't combine that. That's a mistake. I almost fell for that. Oh my goodness. And I remember when I wrote this knowing that a lot of people were going to add these two, thinking that they were going to be like terms. 8 root 2 plus 8 root 3 cannot combine that, because the root 2 and the root 3 are not the same value. They're not the like terms. So don't fall for it. I almost fell for that problem on this live, and I'm so sorry. Anyway, okay, found my perimeter, found my area. Pretty cool. Like I say, I keep saying, you're done with one problem, put it away, go on to the next one the next day. This is all about doing one problem a day for an entire year. And if you can do that, you're going to see that your skills are going to continue to get better, and you're going to have a good time. Guarantee it. All right. Oh my goodness. Well, while we're here, I see that some more people join. Anyone have questions? Anything that you guys want to go over? How about this? Is there a specific concept that you've seen in math class that you just either don't like or you don't understand? Maybe we can review that too. I'm just here to have, to solve math problems, but if there's something that the majority wants to cover, then we can do that. All right. Problem 4. We have another right triangle. I don't know. Something like, Jake, I think it's like 15. I honestly don't know. Yeah, that's a hard one. I'm sorry, dude. Can't help you. Problem number 4, we have a right triangle, and we have the two sides on the bottom, x plus 8 and x plus 10, and we have the hypotenuse. Now, this is a typical problem that people see like in like honors algebra 2, and they look at this and they have no idea how to solve it. But for the most part, you have to remember the Pythagorean theorem. Now, the Pythagorean theorem is going to be a squared plus b squared is equal to c squared. And that's exactly what we're going to use. It's just going to be a little more complicated. We have the two sides, x plus 8 squared plus x plus 10 squared is equal to 10 squared. Okay. Yeah, the quadratic formula, we'll go over that. That might actually occur in this particular problem. Okay, who needs help? A 90 on the test. Which test was that? Okay. Liv got a 90 on her test. That's great. Hopefully the next test. Oh, wait, this is the Liv. I know Liv. Area and perimeter. Oh, okay. Well, hopefully, you have spring break, but I'm hoping that the next test you have after your break is just as good as your 90. Mm-hmm. Okay. Back to this problem. If we're using the Pythagorean theorem, and honestly, the only way we know that we should use that is because we have a right triangle. I'll try to find a problem where we don't have a right triangle and you have to do something else. But if we're going to solve for x, we're going to apply the Pythagorean theorem. Some people call it the ABC theorem, which I think is kind of funny. And I'm going to tell you a common mistake that a lot of people would do here is they'll write x squared plus 64 plus x squared plus 100 equals 100. And that's wrong. That's totally wrong. A lot of people see that, and a lot of students think that's correct, and it just baffles me. Like, you just can't forget that. All right? You have to remember that x plus 8 squared, it's in a parenthesis, so that means that you need to FOIL it. You need to expand it so that it looks like this. Let me go ahead and write that. Let's look at the chat. Okay, so this will become x plus 8 times x plus 8 plus x plus 10 times x plus 10. Now, hey Eliana, same. I'm going through the same thing. I don't understand any of this stuff either. If you're taking algebra 2, we should know how to solve these things. Some people call it distributive property. Those are the elites. The common people like us, we call it the FOIL method. So this will become x squared. Actually, let me show you how we're going to use the FOIL method for those that don't remember it. This is for, okay. This is for someone in the chat. Won't say who. So if we use the FOIL method or the distributive property, I'm sorry, guys. Sometimes in the comments on some of my videos, people go crazy over how technical the term should be. But if I use the FOIL method, that's the way I was taught. You got to remember that you got to distribute the first terms, the outer terms, the inner terms, and then the last. And so that will become x squared plus 8x plus 8x plus 64 plus, I'm just going to go ahead and work on the other one as well. FOIL. And this will be x squared plus 10x plus 10x plus 100. Hope it fits. Oh, what am I talking about? Of course it's going to fit. I forget that I'm on that big screen. All right. Lots of things that we can start combining. If you were here in the beginning of the live, I had mentioned stuff about when we combine like terms. Some teachers really like to show like the shapes. And what I mean by that is I'm going to circle everything that has a like term. So right now I see x squareds that are the only like terms. And then I'm going to go ahead and draw like squares on all the x's. And that tells me that I should only combine those things. And then I'm going to go ahead and let's put a different shape. I'm going to put a triangle around all the constants. So when I combine that, I get 2x squared plus 36x. I can't believe I'm using a calculator for this. Sometimes I just forget how to do my math. It is 36x. And then I have plus 164 is equal to 100. All right. Now, whenever I have a quadratic, hopefully someone in the chat can tell me what I should do. I got to set it equal to what? Anyone? Yo, the chat. Okay. Anyone? What should I do? Ah, Randy. Yes, set it equal to 0. Let's go. So that means that I have to subtract the 100 to the other side. So I get 2x squared plus 36x plus 64 is equal to 0. Okay. Can everyone give me 1 second? I got to get something to, oh, never mind. I'll just wait. I'm so thirsty, guys. This is the second time doing a live, and it's actually a lot harder than doing a Zoom session. And God, my throat's dry. Anyway, all right, so I'm back. Sid, yes, 0. You were kind of late though. Sorry, Sid. Now that I have a 2x squared plus 36x plus 64 is equal to 0, there's so many different ways that I can combine this, or I can solve for this. I'm just going to go ahead and divide everything by a 2. I see everything is divisible by 2, so when I do that, I'm going to get x squared plus 18x plus 32 is equal to 0. Okay. I'm just going to go ahead and erase some of this work so I have enough space. So I get x squared plus 18x plus 32 is equal to 0. And in order to solve for this, I think Sid was requesting the quadratic formula. I can factor it, but just because she was asking for that particular formula, we're going to go ahead and use it. So I'm going to solve this using quadratic formula. And then if there's any geniuses out here, you know that that's probably not the best method, but someone wanted to review it, so that's exactly what we're going to do. So I'm going to go ahead and plug this into the quadratic formula, and I'm going to get negative 18 plus or minus 18 squared minus 4 times 1 times 32 all over 2 times, oh, not a, my a is not 2, it is 1. Peter, what do you mean your humanity hasn't found a simpler way? Just curious. All right, let's go ahead and simplify this. Negative 18 plus, oh, I see what you're saying. That in 2022, humanity hasn't found a simpler way. I know, right? Like, well, technically there's shortcuts and all that stuff, but this is what, I mean, this is what makes math kind of beautiful, that there's an equation that finds it. Now you can just put it into like a simple, you know, calculator, or like you can go online and do it. But I agree. It is kind of weird that this weird equation exists. And by the way, everyone comes up with rhymes for this type of formula. They try to come up with raps, so they try to come up with stories that helps you memorize the quadratic formula. None of them make sense. I feel like that's something that in 2022 someone should come up with. It's not going to be me, but like a nice concise way of understanding the quadratic formula, of memorizing it, because it's just a bunch of letters that sometimes it's either have to be like engraved in your head. But if you, Peter, can find a rhyme or a good way to memorize this, then you're going to be super rich. Okay, so got kind of sidetracked there. All right, guys. So I'm gonna go ahead and start simplifying this. I'm gonna have 324 minus 128 all over 2. X is equal to negative 18 plus or minus 324 minus 128. That's root 196. Okay, who knows the root of 196? That, I feel like that's a nice radical that we should know. Anyone? Randy, dude, Randy, I like you. Randy knows his quadratic. Sorry, I was adjusting my camera there, just because there's like a banging on the wall that my monitor keeps doing. Anyway, Randy, thank you. So we have negative 18 plus or minus 14 over 2, and that plus or minus means that you have your answer is negative 18 plus 14 over 2, which is x is equal to negative 2. I'll put it up on top. Or x is equal to negative 18 minus 14 divided by 2, which is x is equal to negative 16. Okay, now another thing, and a lot of people will get confused because this particular problem has values or answers where the x value is negative. And some people are going to say that x, or this equation, has no solution because the values are negative, and technically that's true, but you always have to remember, you have to check your answers. You should plug in both values into the triangle and see which one is the correct one. So I'm going to go ahead and plug in negative 2 for the first one. So this will be negative 2 plus 8. This is 6, and then negative 2 plus 10. This is 8, so that works. We know that's going to be one solution. Now let's go ahead and plug in negative 16. So I have negative 16 plus 8, which is negative 8. Right away, you can't have a negative length, so we know that negative 16 is not going to be the answer. All right, cool. All right, I think we have time for maybe one more problem, and then we're going to call it a night. What time is it? Actually, maybe I can go for a little longer. Doesn't matter. Um, okay, there's a series one. We can do a triangle. Oh, if Sid and Liv are still on the chat, I know that you guys are covering this. Look at that equation right there, or that problem number 9. That's a good one. That is a good one. Let's see Liv, miss 90%. Solve that. But I'm not going to do that one. Oh, you know what? I'm just going to do this one right here. We have a heptagon, not a pentagon, not a hexagon, but a heptagon. And a heptagon has 7 sides. I hope I got that right. Yeah. All right. So let's go ahead and solve this one. This is like a common one that a lot of students, it's particularly my students, are going over. And all of them are like so confused. None of my students get it. None of my students understand this stuff. And it's just like super frustrating. So we're going to go ahead and go over this one. And we're going to use, actually, let's just go ahead and break this up into multiple triangles. If you notice, we're going to have 7 triangles. So I'm just going to focus on one of the triangles where the radius, not the apothem, is 4. And so what I'm going to do is I need to find the central angle. This one's going to be wacky. Now again, there's 1, 2, 3, 4, 5, 6, 7. So I need to divide 360 degrees by 7 because all the angles in that heptagon add up to 360. So if I divide it by 7, the central angle is like 51.4. So 51.4. And then in that one particular triangle, just the triangles that I'm focused on, I'm going to break that up into 2 right triangles. So I need to split that 51.4 and divide that by 2, which is going to give me 25.7. 25.7. 25.7 right there. Okay, I need to find the base of the triangle and I need to find the height of the triangle because that's how I'm going to find the area of this particular triangle here. So let's focus on just the base down here. I can go ahead and use not Pythagorean Theorem because I don't know at least 2 sides. I'm going to have to use SOHCAHTOA. So this is going to be sine of 25.7 is equal to the base over 4. Multiply the 4 to the other side. And I'm going to get that 2.15 is equal to b. Now, 2.15 is equal to that base, but remember, this was just half of the base because I cut the triangle into 2 right triangles. So my entire base is going to be 4.3. Okay? All right. Hopefully Randy is still on. How do we find the height? If I use SOHCAHTOA to find the base of the triangle, how do I use SOHCAHTOA to find the height? Someone said tan. No, I'm not tan. Not tan up here. Okay, Sid said tangent. Randy is not here anymore to save us, but oh, Sid said cosine. Okay, cos works too. Actually, both work. You can use cosine or tangent. I'm going to use cosine though. So cosine of 25.7 is equal to the height, which is the adjacent, over 4. So I'm going to go ahead and multiply the 4 to the other side and get 4 times cosine of 25.7 is equal to 3.34. I'm using a calculator, by the way. If you think I'm doing these in my head, thank you, but I'm not a genius. I'm using a calculator for sure. Okay, I found my height, which is 3.34. So I can now find the area of this using 1/2 base times height. And that's going to be 1/2 times 4.3 times 3.34. Let me go ahead and multiply that. And I get 7.181. Now, what I just found is the area of one triangle. So back using in the heptagon, I'm just going to put 7.1, 7.181, and technically I can say that all the other ones are also 7.181. And so the area is going to be the sum of all these. But I'm not going to do the sum. I'm just going to multiply 7.181 times 7. And I get that a total area, I'll put it up on top. Actually, let me just erase this. So total area is going to equal to 50.267. All right, nice. Man, I don't know how many problems I've done, but this is the whole point of this book. You practice one problem a day. One problem a day. That's all it takes for you to improve your math skills. You can get this on Amazon. You can get this on my site. I think it's totally worth it. Honestly, it's just nice to open up a book that with math problems that you've never seen before and do one problem at a time. One of the cool things about this book, if you buy the newer version, is it has like a table of contents. So if you're studying geometry or if you're doing like algebra, calculus, whatever, you look at the topics and it has a list of things. So if you want to do like area of polygons, it'll tell you go to problem number 10 or go to problem 12, whatever that might be. So it all depends on like what you're studying. But overall, I just think it's a very comprehensive book that is super useful to everyone. I mean, if I can give one to every student studying math, I would. But I'm not rich whatsoever. See, for example, look, number 12 is a calculus problem. If you can do that one, by the way, I've yet to solve part B. I created it and I totally forgot how to solve it. So if you can solve it and send me the solution, I'll send you 20 bucks. Let's do another problem. We did like geometry, you know, we have some cosines. We did functions. We did, oh, okay. So let's go ahead and let's do one. Bruh. Okay, let's do this one right here. I have plenty of time still. Maybe we can do like one more problem. Let's go ahead and solve for problem number 31. So you have a matrix. We need to find the value of x so that the determinant is 25. Now, if you haven't covered the determinant, this is technically algebra 2. Maybe algebra, but usually algebra 2, perhaps pre-calc. Okay, what's your math problem? Put it in the chat. Let me know. Pretty soon, what I'm gonna do is I'm gonna have like a Discord or like a Google Drive that everyone could just add their word problems. If you want to review homework, that'll be a great way. So like I'll make an announcement, send me your problems over email, and we can go on live and just solve as many problems as we could. I think that'd be really fun. But a Greep something lemma. Oh, dude, you're using a lemma as your username. That's pretty cool. But what's your math problem? If not, I'm gonna start this one up. Let's go ahead and find the determinant of this. Now, the determinant has to be 25. If Randy's still here, how do you find a determinant? Okay, before we start this problem, so would you agree that an exponential gets larger? A number's absolute value gets larger as well. I mean, yeah, an exponential has to get larger. I guess it all depends on the base. So, you know, if we have like 2 to the power of x, that's going to continue to get larger. Because if you do like, you know, 2/3 and you compare it to 2/4, 2/5, that definitely continues to increase. But if we do, you know, if the base in this case is going to be like 1/2 to the power of x, and the number continues to get smaller and smaller. So I guess it all depends. Or we can say if the base is r, then if r is greater than 1, yes. It's kind of like when you do infinite geometric sums. If the absolute value of the ratio is going to be greater than 1, then it diverges. Otherwise, then it converges and we use the geometric sums. A number's absolute. Okay. Hopefully that answers that. If anyone has another question, I'd be happy to answer it. But with this particular problem, we want to find the value of x when the determinant is 25. Now, how do you find the determinant? So if it's a set of integers, then Well, if it's a set of integers, then it's just going to continue to, yeah, increase if the integer is positive. But if it's negative, like negative 2 to the power of x, I mean, it's just going to alternate, wouldn't it? It'll be like 4, then negative 8, and then 16 and all that. Um, yeah, this is fun. If you guys have problems, I'll be happy to chat it up. This is what I do. I love math. We can talk about it all day. Okay, if we want to find a determinant, don't forget that we need it's kind of like the diagonal. We're going to multiply the 2x plus 3 times the 4x plus 4, and we're going to subtract that by the product of the other two values, which is x plus 1/2 times 2x minus 2. How come 0 to the power of 0 is 1, but 0 to the power of 1 is 0? It gets smaller. That's true. Man, that's like the math god. Sometimes, you know, it's the universe just telling you, no, sorry, sweetie, that's not the way it works. I don't know. Let me finish this problem and then we can talk more. Okay. So we want to go ahead and set this matrix equal to 25. And again, don't forget, I don't know who else is on this chat or remembers that we were just talking about how to distribute these things. This is what the elites say, distributive property. We're just going to say that we're going to use FOIL. So we're going to multiply the first, outer, inner, last. For the first parentheses, and we get 8 x squared plus 8x plus 12x plus 12 minus, don't forget these parentheses when you distribute this, especially when you have a negative sign there in the middle. You have to be very careful because technically the entire terms on the right side are going to be negative. So I'm just going to leave it as a parentheses, and then I'm going to go ahead and utilize my FOIL, and I get 2x squared minus 2x plus x minus 1. Okay, so I get 8x squared plus 20x plus 12 minus 2x squared. I'm just going to combine the negative 2x and the x, and that's negative x. So plus 1x plus 1 is equal to 25. Okay, let's go ahead and combine the like terms. So the x squared can combine. That becomes 6x squared. And then we have the 20x, which is plus 21x. And then we have the 12 and the 1, which becomes a plus 13 equals to 25. I think Randy has said this, or it was Sid. I'm sorry. Sid in the chat had said, if we want to solve a quadratic, we need to move everything to the other side so that it's set equal to 0. So we're going to get 6x squared plus 21x. And we're subtracting the 25 to the other side. Minus 12 is equal to 0. Okay. This is where you can use quadratic formula. You can use factoring, whichever method you like. And one of the cool things, bro, go on Desmos and grab this if you want to. You're more than welcome to do that. It doesn't matter. The whole point is for you to just kind of write stuff down. This is, you're not being graded on this. This is literally for you to continue learning on different methods. So if you don't feel like solving this, just like I did, for time, you can just use Desmos, use an equation. I have these free programs that you can put into your calculator. If you go to the link in my bio, you go to the math calculator programs, you can download them. And I literally punched this in as I was talking it, and I found that x was equal to 0.5 and negative 4. So those are the values of x that if you were to plug into the matrix, you will get a determinant of 25. All right. Anyway, keep this in mind. There's 365 of these problems, one problem a day to complete for an entire year. If you do that, I mean, your stuff is going to get, your math skills, your math survival skills are going to get so much better. I guarantee it. And it doesn't hurt to just do a problem one day. A problem a day, that's nothing. That's nothing. Even if it takes you like 10 minutes. I mean, just think about how much time you spent, watching a live. You can easily just solve a math problem while you do that. Maybe I should start going live for like 20 minutes a day so we can do one problem like this. Yeah, so that's going to be it for today. I'm just reading the other stuff. You said, is the sum of all natural numbers really? Dude, that is such a good question. And, you know, a lot of people can discuss that. That's like number theory at that point. I got to bring someone in. I know someone that will love to talk about that. But I think that's a great question to discuss. Um, when it comes to homework, is there something that you guys want to cover for next time? I know a lot of you are going to be in spring break, but when we come back, you know, we can do these types of problems. Um, or we can really, you know, we can cover homework. Maybe next time I'll have like a Discord or you know, a Google Drive that we can cover. Let me take, I wonder if I can switch camera views. I guess, I don't know if I could, but anyway, actually, maybe I can do this. Give me 1 second, guys. Hopefully you guys can see me. Yeah. Okay. I'm going to end this live, but I'm just reading the last of the chats. Do you know about theory of computation? You know what? I was going to major in mathematical computation. I studied a bunch of MATLAB. Ran a lot of programs. And then I realized I don't think I'm that smart for that. So I just did pure math. It's funny how there's all these branches of math, like topology, um, just was not very good at it. I don't even think I could even apply to go into grad school. Like, could I write a thesis on stuff? Probably not. You know, I'm here to help you improve your math survival skills. I can talk math all day, but I'm willing to learn. Yeah. All right, guys. Well, anyway, I got to head out. I hope everyone has a great night. I hope that everyone has a great week. I'm going to try to come back. I really enjoyed this. I think this was fun. All right. Anyway, peace out.